So what is adiabatic process? It is a thermodynamic process in which there is no heat exchange between system and surrounding. So let us say we have a system and we have surrounding, and we have a adiabatic process. So in this process, basically there is no heat exchange. Mathematically this can be written as Q is equals to 0, where Q denotes heat exchange between system and surrounding. So heat exchange between system and surrounding. Now we are interested to find equation for adiabatic process. So what is the equation for adiabatic process? And this can be done by using first law of thermodynamics. So what is first law of thermodynamics? That is delta E is equals to Q plus W, where delta E denotes change in internal energy. Q denotes heat exchange, and W denotes work. We know for adiabatic process Q is equals to 0. So we can write first law of thermodynamics for adiabatic process, that is delta E is equals to Q plus W. So this becomes delta E is equals to 0 plus W, because for adiabatic process Q is equals to 0. So we will have simply delta E is equals to W. So for adiabatic process we can write first law of thermodynamics, that is delta E is equals to W. Now let us write expression for work and internal energy. W is written as minus P dV, where P denotes pressure and V denotes volume. And change in internal energy delta E is given by NCV dt. So where we have N is number of moles, CV is molar heat capacity at constant volume, and T is the temperature. Basically CV can also be written as R by gamma minus 1, where R is the gas constant and gamma is the molar heat capacity ratio. That is Cp by Cv. So gamma is simply Cp by Cv. So this expression, that is Cv is equals to R by gamma minus 1, can easily be proved. That is, we know Cp minus Cv is equals to R, and we also know Cp by Cv is equals to gamma. That is, Cp is equals to gamma Cv. So from equation 1, we can write, that is gamma Cv minus Cv is equals to R. So if I take Cv common, we will have gamma minus 1 is equals to R. So from here we can write Cv is equals to R by gamma minus 1. That is the same thing. So now we have, for adiabatic process we have written, that is delta E is equals to W. And delta E is given by NCV dt, and work is given by minus P dV, and Cv we can write, that is R by gamma minus 1. Now we have three variables: temperature, volume and pressure. So basically we have this time three variables. We can change into two variables if I apply ideal gas equation. That is PV is equals to nRT. So from here we can write T is equals to, or basically we can write P is equals to nRT by V. So we will eliminate pressure. So we will have, pressure can be written as nRT by V. Now nR cancels, so we will have dt by gamma minus 1, and this is dV by V into temperature. Now let us separate the variable, that is take T this side. So basically we have separation of variable. So we will have dt by T is equals to gamma minus 1 dV by V. Basically we have a minus sign also here. So this is the minus sign. So we will have dt by T 1 minus gamma dV by V. Now let us integrate both sides from T1 to T2, and volume is from V1 to V2. So this integration will be ln T2 by T1, and this side we will have 1 minus gamma ln V2 by V1. If I take 1 minus gamma inside the log, it will become power. So ln T2 by T1 is ln V2 by V1 raised to the power 1 minus gamma. Or we can write ln T2 by T1 minus ln V2 by V1 1 minus gamma is equals to 0. Or this can also be written as ln T2 by T1 V2 raised to the power 1 minus gamma v1 raised to the power 1 minus gamma is equals to ln 1, because 1 log of 1 is 0. So this we can write ln t2 v2 gamma minus 1 t1 v1 gamma minus 1 is equals to ln 1. So we will have this is equals to 1. So we can write t1 v1 gamma minus 1 is equals to t2 v2 gamma minus 1. So from here we can say adiabatic process will have equation tv gamma minus 1. This is equals to constant. So this is the equation for adiabatic process. Now we can also write same equation in terms of pressure and volume, because we know PV is equals to nRT. So temperature is equals to PV by nR. So if I plug the value of temperature in this equation, we will have PV by nR. V to the power gamma minus 1 is constant. So this becomes PV gamma is equals to constant multiplied by n into R. So this is another constant. So we can write PV gamma is equals to constant is also equation for adiabatic process. So either we can write TV gamma minus 1 is equals to constant, or we can write PV gamma is equals to constant.